I'm going to do a quick review of what you should have done on Wednesday, just in case you were confused. So I'm going to go over the examples for graphing polynomial functions, and then I'm also going to go over the examples for graphing rational functions. So by the time I return, this assignment should be complete and ready to be turned in. Please remember, I don't accept late work. So graphing polynomial functions, before we start, we have to look at our chart for summary of end behavior with no graph. So remember, the leading degree is your highest exponent, and then your leading coefficient is going to be the number in front of your x. So when I look at example 1, I have f of x equals x to the third, open parentheses, x minus 1 squared. So this form is in factored form, and it can be easy for me to find my x-intercepts. But it's going to be a little bit harder to identify my end behavior. So since it's in its factored form, I have to add the exponents of each of my factors to find my leading degree. So that means I have 3 and 2. So that means my leading degree is 5. And those are e's. Okay, so then my leading coefficient, there's no number in front of both of my x's, so my leading coefficient is just going to be a positive. And I don't know why my mouse is not working. So my leading coefficient is positive. So I'm going to go back to my chart, and my leading degree is odd, and it's positive. So on the left-hand side, my arrow is going to face down because that's negative infinity, and on the right side, my arrow is going to face up because that's positive infinity. So I'm going to put down arrow on the left and up arrow on the right. So now I have to find all my x-intercepts. So I'm just going to take my factors. My first factor is x to the third, and I'm going to set that equal to 0. So that means in this case, x is just going to be 0. So I'm going to put a dot when x is equal to 0, and it's going to be right here. And then I'm going to take my next factor, x minus 1 squared, or just x minus 1. And I'm going to set that equal to 0. So that means x is going to equal a positive 1. So I'm going to put a dot at positive 1. Okay? And when we're looking at multiplicity, multiplicity is basically just the exponents on your factors. And so if I go back and look at my two factors, I have x to the third, and my exponent here is to the third power. So that means at 0, my graph is going to go through the x-axis because it's an odd number. And then if I look at my next factor, which is x minus 1, my multiplicity, or my exponent, is 2, which is even, so that means it's going to bounce off the x-axis, so that means it's going to be some kind of U-shaped. And then I'm just going to put arrows at the end, and that's my graph for example 1. So if I'm looking at example 2, if I look at it, this is in expanded. So if you look at example 2, this is expanded form because each one of these terms are separated by a plus or a minus. In this case, it's a minus. So identifying end behavior is a lot easier because I'm just going to look at the leading degree, which is 5, and the leading coefficient, which is 2. So those two numbers are going to tell me where my arrows are going to face in the beginning, and it's going to face down and up. Okay. So finding all my x-intercepts is going to be a little bit more difficult because I have to actually factor it. So if I have 2x to the 5th power minus 3x to the 4th power, since they don't give me any factors, I have to look at these two terms and I have to figure out what do they have in common. Well, they both have at least 4 x's, so I can factor out 4 x's. So I'm going to have x to the 4th on the outside of the parentheses. So that means on the inside, when I take out 2x to the 4th, I'm going to have 2x minus 3. So now all I'm going to do is I'm going to set both of my factors, x to the 4th and 2x minus 3, equal to 0, and those are going to be my x-intercepts. So if I set x to the 4th equal to 0, that means x is going to be 0. So that's my first x-intercept, so I'm going to put a dot at 0. And then I'm going to set my next factor, 2x minus 3 equal to 0. So that means x is going to be 3/2 or 1.5, because we know 3 divided by 2 is 1.5. So I'm going to put a dot at 1.5 right here. Okay. So now to graph the rest of my line, I'm going to identify my multiplicity. And remember, that's just the exponents for each x-intercept. And so if I look at x to the 4th, my multiplicity or my degree is to the 4th power, my exponent is to the 4th power. So that means my graph is going to bounce off the x-axis when x is 0, so it's going to look something like that. And then my exponent for 2x minus 3 is 1, so that means it's going to go through, so this graph has to come back up somehow and go through the x-axis when x is 1.5. So my graph should look something like that.